Hello, good afternoon all. My sound, I am audible to everyone. Hello, am I audible to everyone? So see, the unit 4 is divided into two parts. First part is the heat treatment and second is the so first part is the heat treatment and second is the testing of material. See, at a point of view from mechanical engineer, heat treatment can be considered as one of the manufacturing processes. Uh, so it is very important that you should have a thorough understanding about this heat treatment, what is meant by heat treatment, how the heat treatment affects the structure of a metal, uh, what are the basic heat treatment terminologies, classification of heat treatment like annealing, normalizing, hardening, tempering procedure, uh, uh, how how actually heat treatment works, uh, what is meant by TTT diagram construction, heat treatment based on the TTT diagram. All these topics are covered. We have to cover in this uh, unit. So there is a first lecture on heat treatment. I will give introduction about the heat treatments. Uh, so uh, let's start. So basically, heat treatment or heat treating is a group of industrial and metalworking processes used to alter the physical, sometimes chemical properties of a material. The heat treatment is the heating and cooling of a material at a specific rate to change the physical and mechanical properties without letting its the shape uh, without letting it change its shape. इसमें शेप में भी फर्क नहीं पड़ता है अगर शेप जैसा भी हो जैसी भी साइज हो तो वही रहेगी बट the mechanical properties will get improved. Uh, this process of heat treatment involves the use of heating or cooling, usually to extreme temperature to achieve the wanted result. Sorry, it is very important manufacturing process that can only be help manufacturing process, but also improves the product and its performance. And it characterized by the many ways. Heat treatment techniques include annealing, case hardening, precipitation strengthening, tempering, normalizing, quenching. By heat treatment, a metal can be made harder or stronger and more uh, resistance to impact. Uh, Heat treatment can also make a metal softer and more ductile. हाँ? So take an example of potato. हाँ? आप पोटैटो को अगर बॉईल करते हैं तो क्या होता है, पोटैटो सॉफ्ट हो जाता है। हाँ? क्या पोटैटो सॉफ्ट हो जाता है। सिमिलरली टेक अ एग्जांपल ऑफ एग। एग को अगर आप बॉईल करते हो तो एग हार्ड हो जाता है। सो हाउ दिस इज हैपनिंग, बिकॉज द हीट ट्रीटमेंट हैज अ different effect on a potato and egg. So, and the final product is different. Uh, Similarly, if I have to give the real life example, if you heat a steel, uh, any steel, any iron product, uh, any iron alloy, right? Steel, cast iron, uh, any iron, FeL, iron alloy.
हेलो
Uh,
सर, वॉइस कम आ रहा है सर।
हेलो हेलो, अभी आ रहा है ठीक?
यस सर, बहुत ही कम आ रहा है सर वॉइस।
हेलो हेलो। So I just told you to
सर
take a,
आवाज कम आ रही है सर, कम आ रही है।
आ ही नहीं रहा एकदम। वो तो माइक एकदम पास लेके
सर
बैठे।
सर बहुत ही कम आ रही है आवाज।
हेलो। So take an example of any iron alloy. If you heat it about 900 degrees Celsius and place in a furnace to cool down, that is slow rate of cooling, very slow rate of cooling. Uh, or you place that iron rod in a sand, in a molding sand, so that the cooling rate is very slow. Then the microstructure of iron get converted to such that the material became very soft and uh, and a ductile. Uh, if you put that iron alloy from 900 degrees Celsius into water, that called as a quenching. Uh, that called as a quenching. That same iron rod become hard and brittle. Uh, so uh, depending on the property of final product we required, uh, we can achieve that final property with the selection of proper heat treatment procedure. So this is how the structure of material altered by the heat treatment process, and that new structure gives rise to the new mechanical properties or improved mechanical properties. Uh, These are the some importance of heat treatment. Importance of heat treatment are listed here down. Uh, it relieves some internal stresses causes due to the cold working process or hot working process. It softens the metal. It improves the hardness of metal surface. It improves the machinability. If material is soft, its machinability is improved. It improves the grain structure. uh, Depending on the application, if we require a fine grain structure, that is small grain size, can be achieved. Uh, if we required coarse grain size, that is bigger grains, that can be again achieved with the help of heat treatment. So refining of grain structure is possible. To improve the mechanical properties like tensile strength, ductility, shock resistance, all can be improved. All can be improved with this method. With this method, to increase the resistance uh, to wear, tear, heat, and corrosion, can be also achieved with the heat treatment with the proper selection of heat treatment. So I just give the example of heat, tensile strength. Uh, Generally, if you want to increase the tensile strength, grain size should be minimum. Uh, Grain size, if you want to reduce the grain size, you have to increase the cooling rate. You have to increase the cooling rate. Huh? All of you must have gone through the iron carbon diagram. Can anybody tell me in an iron carbon diagram, in a steel range about 900 degrees Celsius, which phase exists? Huh? Above 900 degrees Celsius, let's say 0.8 percentage of carbon, which phase exists? It is austenite, denoted by alpha. It has a crystal structure of FCC. Uh, it has a crystal structure face, center, cubic. Uh, uh, if we cool that austenite uh, very fast, we get alternate layer of ferrite and cementite. It is called as a perlite. Uh, if we even go faster cooling, so very fast cooling, that is water quench, water or oil quench, uh, we get a formation of martensite. What is martensite? Martensite is an intermediate phase between austenite and ferrite, because I am not allowing any austenite to get converted into ferrite. Uh, so the crystal structure conversion from FCC to BCC, I am not allowing this conversation because I am applying very high cooling rate. So the atom arrange themselves into a structure known as a body center tetragonal, BCT, body central tetragonal, and that structure is called as a martensite. Martensite improves the tensile strength and hardness because it is very hard phase. It improves your tensile strength and reduces the ductility. So this is a typical example I want to give you for increasing the tensile strength. See, what are the stages in a typical heat treatment cycle? First is the heating of metal slowly to ensure the uniform temperature. Second, second, uh, second, shocking, stocking, holding the material at a temperature for a given time and cooling to metal to the room temperature. Soaking means the same smoking we do for our clothes. Huh? What we do, we add a washing powder, add a cloth, allow it for 20 minutes of soaking. So here also, once you decide the temperature, at what temperature you want to heat a metal to get your desired heat, desired mechanical properties. Once it is decided, once it is decided, so after achieving that temperature, we allow the metal for a soaking. Here, we follow simple thumb rule for soaking. Uh, and the rule is and the rule is 1 inch is equal to 1 hour of soaking. For 1 inch of a thick metal, we allow 1 hour of soaking. for a steel sample. And similarly for aluminium, it's sometimes lesser than 1 hour because the aluminum conductivity is more compared to the steel. Uh, we follow this thumb rule. Uh, what is the thumb rule? For 1 inch thick metal, 1 inch thick metal, 1 inch thick metal, we soak the metal for a 1 hour. If our metal is three inch thick, uh, then we soak it for 3 hours. If our metal is half inch thick, we soak a material for a half an hour. And stage 3 is a cooling of metal to the room temperature. So also the rate of heating, uh, rate of heating also affect the mechanical properties. Rate of cooling also affect the uh, uh, what the what I can say, mechanical properties of a material. Soaking period also affect the mechanical properties. So proper selection must be done before you apply a heat treatment procedure based on your final uh, final product or final properties you want to achieve. Based on this soaking time, type of cooling, uh, the heat treatment process are classified as follows. First is annealing, normalizing, benching and hardening, benching or hardening, tempering, surface hardening, case hardening, Oz tempering. Yeah? Annealing means very slow rate of cooling. Normalizing means somewhat faster to the annealing. Yeah? Quenching and hardening, very high rate of cooling. In tempering, we cool, we cool, we cool to intermediate temperature and hold it for some time, and then we allow it to cool to the room temperature. That means intermediate cooling or tempering we called as. Sometime after hardening, we go for a tempering. We improve the toughness. Then surface hardening. If surface hardening, only surface is hard. Other is other metal kept intact. Case hardening, only some part of see you see the gear tooth, yeah? Only the tip of gear is harder in case hardening. Yeah? Os tempering is also similar to the tempering. After heating to high temperature, it cools, it suddenly cools down to intermediate temperature, and after that, uh, allow that material to soak at that intermediate temperature and cool down. And same also depending on properties and the temperature, the further two classifications are also given. The first is a annealing. Uh, Annealing, it is heat treatment process that alter the physical, sometimes chemical properties to increase the ductility and to reduce the hardness. It making material more workable. See, once you cold rolled up some material, it get work hardened. And if you go directly for further cold working, the material will break because it get work harder. The very high internal stresses are developed during that cold working procedure. Hence, hence we go for annealing heat treatment, and after annealing heat treatment, uh, uh, and after it's what after annealing heat treatment, some internal stresses get relieved, and so that's why the work hardened effect is also get nullified, and and though and the material reaches to the original mechanical properties. Hmm. See, let's consider a 100 thick slab of uh, metal uh, that are rolled, let's say 20%, so slab thickness get reduced to uh, 80 Now, after that reduction, or with that reduction, that metal get hardened. So, if we further reduce by 20%, I have to apply more force. So under that more force, metal may get break because that properties are changed. Properties are changed. The material is hardened. Uh, it may it stop for you.
विनायक
1
सर
second.
विनायक सर आपण
Uh,
हॅलो
so
हाँ 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 भेज देता हूँ ठीक है
so student, I have to go for the committee meeting urgently. So I am stopping here. Uh, so thank you very much.
जाओ सर मैकेनिकल डिपार्टमेंट कमिटी कमिटी आ गई ना अपने बालू पर
Uh-huh.
तो आपको बुलाए